speaker. Professor Matthew Lund is a sort of associate professor of philosophy at Rowan University. He's a sort of dearly beloved colleague of all of us, and has been here since 18 years now? 2004. Slightly after me. Ha! I beat him. Anyway, and he is, the author of a number of works on Norbert Hansen, as well as, a number of other works in philosophy of science. He does a bunch of editing work in history and philosophy of science, and has also been working for some time on kind of issues surrounding kind of the Royal Academy, which is going to be the sort of, subject of today's talk, which is entitled, here it is, Precious Memories, Persisting Institutional Bias in the History of the Royal Academy. And I'd like to ask everyone to help join me in welcoming Professor Lund.
All right, well, thank you, Ed, for the great introduction. And I can't say how good it feels to be in a room full of people listening to me instead of behind a screen. So this is kind of exciting. I'm kind of not even sure what to do or where to stand and all that. So anyway, I hope you bear with me on that. So before I start the talk, especially given the nature of the theorizing talks, I feel like I should sort of contextualize how it is that I ever came to think about the issues that I'm talking about here and why they matter to me. So as Ed mentioned before, my original research was on this philosopher of science, Nord Russell Hansen, who championed this notion that observation is theory-laden, that anytime you observe the world, you observe it with some conceptual set, some set of expectations. And otherwise, you couldn't see the world in an intelligent way. And I'd always read about this thing called the personal equation, and people would mention it and say this weird thing happened in the history of astronomy where they noticed that as hard as they tried, these observers would differ from one another. And it took a long time. It took nearly a century for people to figure out what was going on. And this seemed fascinating to me. Like, how does our sort of neural and psychological circuitry mesh with our experience of things? Do those things align in the way that we hope that they would align? And so that's sort of where I got into this question. And I wrote a really long paper. It's over there, and I'm not going to read it to you because I wouldn't have time and you wouldn't want to hear it anyway. But it's a paper that's about the activity of Friedrich Bessel, the great Prussian mathematician and astronomer, who really sort of resolved this whole set of issues. And I'll have some occasion to talk about him in the early part of the talk. But as I dug into this, there's an event that happens at the beginning. This is sort of like the Garden of Eden story of the personal equation, where this unfortunate guy, David Kinnebrook, gets fired, and only years later, so he gets fired in 1796, and it's in 1823 that Bessel kind of discreetly publishes in a 4-page preface to a 500-page book of observations, a little experiment that he did that sort of showed that there's really this phenomenon called involuntary personal constant differences in observation. No one paid any attention to it. Much later, towards the end of the 19th century, psychologists started digging into physiology. People like Helmholtz were digging into how, neural transmissions and nerve transmissions in frogs operated and all these kinds of things. And suddenly they started looking at the personal equation and saying, hey, maybe that's what explains this problem. So it became a vogue problem a long time after anybody in astronomy was looking at it, which is interesting. And then one more little bit of prefacing. When I was investigating what had happened with Kinnebrook and his whole story, I ended up getting his letters from the National Maritime Museum, and I was kind of astonished when I read them because he had all these accounts of arguing with his boss, Royal Astronomer Neville Maskelyne, and protesting that he was observing just as well as Maskelyne had. And he even shows all kinds of evidence of Maskelyne having differed from other people in the past. None of this, to my knowledge, has ever been referenced or cited in any way. I find this kind of extraordinary because one might have thought that this whole discovery of the personal equation might have happened 25 years earlier had anybody paid attention to what Kinnebrook was talking about. So in my epistemology class, just yesterday actually, we were talking about standpoint theory and feminist epistemology and sort of like, why is it when people read these histories, certain people say things and nobody cares what they say, and other people say things and everybody's like, oh yeah, this totally has to be right. And I had this feeling every time I would read about Maskelyne's kindliness, his fairness, that he was a hard taskmaster, but he didn't suffer fools gladly, and all this sort of language. The more I read it, the more false it seemed to me, the more actually repulsive it seemed to me. So anyway, that's the backstory for the piece. Okay, so I've said some words about kind of perceptual relativity as this became problematic. And it's interesting that during this period of the 1790s, you have these two very interesting discoveries about limitations of human perception. So here's a picture of John Dalton, the great chemist. It's little known that his first publication was actually on color blindness. This before anybody knew about him as a chemist. And Dalton was a Quaker, and he went to buy his mother some cloth so she could put a dress together. And of course, you have to be very modest if you're a Quaker, so the cloth was supposed to be gray, but he bought pink, which is just a terrible thing to do. And he later recognized that both he and his brother were colorblind, which we now know makes sense. And in many European languages, the word for colorblindness has to do with Dalton, as in French. So it's only that old. We think of this as a basic part of human perceptual experience we all know about, but it's only 200 and some years old. A little while after this, of course, Kinnebrook gets fired due to his late observations by Neville Maskelyne. Then again in 1823, I guess I can do this, right? Bessel did these tests. He actually did comparative tests with another astronomer who came to work with him, Wahlbeck, and they had similar differences. And he chronicled all this and tried to rule out sort of potential causes of the difference, and he was unable to do this. And he came up with a pretty good conjecture as to why it happened. He said some people will listen for the tolling of the clock, and I'll show you what this means in a little bit, and then they see the star moving, and others key on the motion, and then they hear the sound, and there's going to be a different sort of delay, like a hysteresis delay, we might say, in those cases. And that was pretty well right. We see it's only in 1833 that the Astronomer Royal John Pond, who was the sixth Astronomer Royal who came after Maskelyne, coined the expression personal equation. They were only used in what we call reductions in the 1830s by Gerling, who was sort of a colleague of Bessel in geodesy. And then you can see later these became standard parts of the observations. If you had a bunch of observers observing, they would have their personal equation periodically measured, and this would be put in the observations, and you could use it to translate from one person to another as a reduction. And then finally, towards the end of the 19th century, psychologists picked it up, like Sigmund Exner, and they came up with these notions like reaction time and so forth. So this is what would happen over the course of about a century. You know, people were developing notions of relativity and perception. I'll go through this somewhat quickly. If we look at how this worked within astronomy itself, you had personal equations getting published in the 1840s. Then there was this thing, this is called the American method of chronometry, where these galvanic chronometers were put together, which was like a big drum that would roll paper, and you could push a little key and you would get the time exactly. Those came out in the 1850s, and they sort of got rid of the problem because people would be watching and they would see when the star crossed the wire and they would push a button. Then in the the 1880s, the American psychologist E.C. Sanford published some really influential papers, actually 3 papers from 88 to 89 on the personal equation. And almost everything that's been written since then refers to all the same sources that Sanford had. And then later, this is kind of a curious one. Edwin Boring, who was a professor of psychology at Harvard, wrote this book. I actually have the book right here. It's called A History of Experimental Psychology, and it's big and it's thick. And he says, importantly, that Kinnebrook was fired by Maskelyne, as every psychologist knows, for marking the transits too late. And he made that story a big, important story about experimental psychology, kind of anachronistically. And this book is funny. It has in the beginning, there's a map. You can't see it, but it's a map of Germany, as though this is all that matters when it comes to psychology. There's also a little plate, and it's a photo of Wilhelm Wundt. Okay, so in 1929, this is the sort of patron saint of psychology. So all of this is quite interesting. And this is a really well-researched, really deep and great book, I think. But I think the part he writes about this is fairly wrong-headed. So that's sort of how people have remembered the issue, is based on the way Boring framed it. Okay, so I'll talk for just a few minutes about Bessel. Here he is in his sort of glory, looking like Beethoven or Lord Byron, very great 19th century sort of painting. He lived long enough to have photos taken of him, and he kind of looked like that, so it's not that bad of a likeness. And Bessel was a really interesting person because he came from really low beginnings, and he ended up working as a clerk in a mercantile house in Bremen. And he loved astronomy so much that he would stay up all night teaching himself mathematics, doing astronomy, made his own telescopes. And he sort of, during these late night lucubrations, he calculated the orbit of Halley's Comet based on some old data that had only come to light at the end of the 18th century. And he's so impressed Olbers that Olbers got him a position as an assistant astronomer, just like Kinnebrook. And eventually, he solved so many problems, he was so talented that he was allowed to oversee the construction of a new observatory in Königsberg, which was really one of the very best observatories there was. And he had a lot of money to spend on all of this. And so extremely important in astronomy's history. He was the first person to measure stellar parallax. Actually, in the same year, 2 other people did it after he did. And what this is as our entire solar system is revolving around throughout the year, the Earth goes around the sun, and the positions of certain stars will change relative to one another. And this had been known since the very early sort of theorizing about heliocentrism. And the ancients said, well, the Earth can't go around the sun because we'd see the stars change positions relative to one another. And Bessel was the first person to be able to prove it. And it was just as much a theoretical as an observational feat. He also was on the cusp of discovering Neptune when he died of stomach cancer in 1846. So he was not the discoverer of Neptune, unfortunately. This I won't get into deeply, but this is a really important part of the story. He sort of single-handedly came up with an entirely rigorous general system of what are called reductions. So these are both what are called astronomical reductions, where you sort of figure out the mathematical contributions of stellar objects and sort of like, how is the speed of light affecting where I think this star is? How is the rocking of the Earth affecting where I think this star is at? How is the refraction of the atmosphere affecting this? How is the coefficient of expansion on my telescope mounting affecting this? how is the gravitational pull on my telescope down towards the ground affecting what I'm doing? So he ends up writing a 50-page preface to one of his one-year catalogs of observations, just laying out a theory of reductions. And this blew people's minds. It blew astronomers' minds. It was so impressive and rigorous. But that's not what I'm going to talk about. Now, here was a little excerpt. This is actually translated by E.C. Sanford from his preface, where he talks about the personal equation. And now that I have so much text up here, I'm realizing it would be really tedious if I read all of it, but I'll try, at least for this one. So he talks a bit about the sort of observational setup, and then he discusses Maskelyne and Kinnebrook at the end, and he says, if one considers that Mr. Kinnebrook must have wished to observe the transits earlier again in order to approximate what was considered entirely correct, then one can no longer doubt that an involuntary constant difference can take place between two observers, which clearly exceeds the limits of accidental uncertainty. This is a word philosophers vex over, can, and in the original German, it's very similar to this. Like, what does that can actually mean? Does that mean it's really true? So, yes. So getting back to what I was saying, what's particularly interesting about this quotation is that you can see that he's actually basing the possibility of the personal equation and perhaps the actuality on a reconstruction of this dramatic situation between Maskelyne and Kinnebrook. Everyone who talks about Bessel says his reason for believing there were individual constant differences were his experiments. But he doesn't himself frame it that way, which is really interesting. It's a case where you have to forget what everybody says and read what somebody actually said. Okay. All right. So this is all very important because it's a case where our sort of phenomenology of perception and how the world is don't seem to nicely lay on top of one another, and that's disturbing to people. Maybe it shouldn't be, but it is. And it was back at this time. And one of the things that this undermined was a view, kind of an Enlightenment view that astronomers in particular had, that if you really were well-trained and you were diligent and you rose above your passions and all these other inclinations and you just focused really hard, you would get it right. And that was a really comforting view for people to have. It also made it so that expertise and sort of social prestige were kind of one and the same, and that was convenient. And it turns out not to really be true. It didn't stand the test of time. And so that was one of the things that was undermined here. And so, as I say, quoting Christoph Hofmann, Bessel's discovery definitively destroyed the older conception of the astronomical observer as the skillful master of an art. That was no longer a view that people could maintain after Bessel's disclosures. Okay, so I'll try to go a little bit faster. I talked about that stuff as much as I did because I'm trying to set the stage to show why the rest of what I'm talking about is important, and I'm assuming that not many of you would know this story. Okay, so as I say, every description that I've ever read of Maskelyne and Kinnebrook is told from Maskelyne's perspective. However, in 1985, someone came forward with some letters, and these were almost 100 pages of letters exchanged between Kinnebrook and his father, all during the period and shortly after his firing, but during the period that he was the assistant to the royal astronomer. And so you get a real inside view of what Kinnebrook was going through. And one would have thought that would have been sort of a gold mine for historians who write about this to say, you know, what did he actually say? What did he do? What really happened? And to my surprise, the only parts of that set of letters that are culled are the ones that sort of fit in with the narrative that said that he was kind of a hapless loser, kind of a misfit, and he didn't do a very good job and he got fired. And here's kind of some examples of how he and Maskelyne didn't like each other. But there's a lot more in there. And so that's the bit I'm going to talk about in just a sec. Okay, so here is Neville Maskelyne. This is an interesting portrait he had done. And this is from 1785 when he was in middle age, I suppose. He got married really late and he had just a single daughter, and this was right around the time that she was born. And I could go into the sort of the iconography of the painting, like how he's got his hand on top of the observations, and in his hand is a work of optics, and in the background you can see the Royal Observatory. And we go into a lot of detail about what's here. And this was a family portrait. And it's now owned by the Royal Society, and it's proudly placed in a prominent position. You can also see he's got clerical robes on, so he was a divine. Actually, every astronomer royal was a divine until George Biddle Airy in the 1830s. And this caused a lot of vexation for Airy. It was expected that the astronomers royal would all be divines. I brought this book with, a very nice book, I think, but a very loathed book by people who write about the Royal Observatory, Davis Sobel's book, Longitude. And in this, she says, a story that hails a hero must also hiss at a villain, in this case, the Reverend Neville Maskelyne. And this book is about the horologist or clockmaker John Harrison, who eventually won this 20,000-pound longitude prize. And it turned out that Maskelyne was the head of the board to determine who would win this, but he also had his own way of determining longitudes, the lunar distance method, and so he was trying to win it himself. And they actually even wrote into English law that you couldn't use the technology put forward by one John Harrison. So I think in a large measure, Sobel is right to say that he was kind of a creep when it came to all this stuff with Harrison. But a lot of historians will say her book is entirely misleading. She went to a horology conference in 1993, and that was the basis for her book that came out in 1995, and on and on and on. And honestly, I don't know enough about that to act as a judge in that particular hearing, so I'm not going to say anything more. But I think what that did was it got people really defensive about Maskelyne. It made people really be on guard for mere journalists staggering into their sort of sacred domain and saying reckless things, although very entertaining and very readable things. So if you haven't read Sobel's book, I recommend that you read it. Sobel actually came to Rowan about 12 years ago, and she gave a really nice talk, and she showed a picture of herself when she was 20 to all the students who came and said, "See, this is what I look like. I look just like you." And I went on to write interesting things and lead an interesting life. I was very impressed by her, so I'm sort of partial to Sobel anyway, because I thought she was a very interesting and nice person, and a very good scholar too. A couple of the other things I should say about Maskelyne, things that he really deserves credit for, was he started regular publication of the observations. Shockingly, for the first 100 years of this institution of the Astronomer Royal, no one regularly published anything. In fact, they tried to take the observations when they were done. They tried to get the Royal Society to, like the family members, the heirs would try to get the Royal Society to pay them for the observations. And Maskelyne took his job seriously, and he started regular publication. He also started in 1767 the publication of a really important periodical called the Nautical Almanac, and he actually spent arguably more of his time on that. He had scores of computers, people who did computations at home for the Nautical Almanac spread all over England, and so he had to coordinate this massive editorship. And he was a really good organizer. You know, this was one of his great talents. When he was young in 1761, there was a transit of Venus across the face of the sun. And these only happen twice a century. They're super important events. And at this time, everybody knew if we could if we could really mark this out well, we would know how far away the sun is, and then we can reform our astronomy. He actually went on a voyage with Mason and Dixon, who you'll know from the Mason-Dixon line, because they were also cartographers at this time. And it was as a result of that that he petitioned to become the Astronomer Royal, which he then later was. Okay, so, and he was Astronomer Royal for a long, long time. I believe it was 46 years. And this, I've shown this before, but I can't resist showing it again. So this is his observing suit. And here I quote a friend of mine and somebody I couldn't have done anything without, Bill Sheehan, who doesn't share the love for Maskelyne that some others do. So he talks about how as Maskelyne aged, he became very into gluttony, and he became very fat, and he was worried about being too cold, and so he had his brother-in-law send him all this silk from India so he could make this very fashionable observing suit. And as Bill says, produced a kind of huge body sock for him to wear at the telescope. He must have looked like a gaudy silkworm wrapped in its cocoon. So that's a very, very unflattering view of Maskelyne. But he had, over the course of his time as Astronomer Royal, he had 24 different assistants, so they were in and out all the time. And the business of astronomy at this time, positional astronomy, was really boring and really exhausting. And so he wanted to have an assistant to get up at all hours of the night to make these observations, not do it himself. And this is another famous picture of Maskelyne. Sorry I didn't give the credit on here. And here's a quote from Mary Croarkin, again, a historian who has been very generous to me and helped me out a lot finding all the sources that I have. And this is from a book that Rebecca Higgett edited, which is a series of essays about Maskelyne from 2014. And generally the book comes off a little bit like a hagiography, like a life of a saint. They're talking about how kindly he was and how much he cared for people. And so this is sort of a moderate comment in light of all that. So Croarkin says, despite Maskelyne being portrayed in popular literature as a self-seeking academic astronomer with a less than personable style, the stories of his interaction with the Nautical Almanac, Human Computers, reveals that he went to some lengths to provide stopgap employment to mathematically inclined people, helped out their families, and then I italicize this bit. However, as David Kinnebrook's story and that of other Royal Observatory assistants show, Maskelyne was a hard taskmaster who did not suffer those he considered fools gladly. And I think the letters might make a pretty good case that he was a bit more than just a hard taskmaster. He was maybe kind of a micromanaging, stuffy jerk, something like that. I mean, that's what I would probably call him. Okay, so I should have said this at the beginning, and I'll say it at this time, but the gist of all this was the observatories across Europe, the Royal Observatory in particular, was employed in doing what were called right ascension observations, and this was with what was called a transit telescope. And here's a very old sort of drawing, woodcut of the Danish astronomer Ole Rømer. And you can see the telescope, I don't know how well you can see it, but it's got a sort of horizontal axis and it's mounted on some heavy piers. And that's all to keep it from wobbling this way. And what you would do is you would look out to the south and you would find your particular star and you'd go up and down. So if you think about the Earth, we have latitude and longitude. When it comes to the stellar globe, we have ascension and we have declination. Declination is actually the up and down bit, and ascension is where everything crosses. Now, it turns out that for navigation, ascension is extremely important because you can't tell where you are in terms of longitude without it. In the old days, and that would be the time of Kinnebrook, there were two devices used, a transit telescope, or sometimes it's called a transit instrument, to measure when the star crosses. And then there was another thing called a mural quadrant, which is, or in German, it's a Mauer telescope, which means it's a telescope mounted on the wall. and this one would just give you your declination. Later on, there was a device, actually at the end of the 18th century, this device was in use by Giovanni Piazzi in Italy, called a meridian circle. And this actually had one telescope where you would measure right ascension, and you could also measure declination. And that really improved accuracy. But at this time, astronomy had a lot of cachet, and it got a lot of money because it was so essential for navigation. You had really terrible naval disasters. In fact, that's why the Longitude Prize was 20,000 pounds, because there were some horrible catastrophes. Kinnebrook, as I say here, his observations were seen to be a half second to 0.8 of a second slower than Maskelyne's when they did comparative tests. And that would amount to about a 1/4 mile of longitude error at the equator. And so this was considered a serious problem in a theoretical way, although if you were actually trying to navigate a ship, that was still within your visual range, so it probably really wasn't a big deal. It wasn't a practical problem, but it could be seen as embarrassing enough that people might not trust what's going on. Okay. Now this is a drawing of the 8-foot transit instrument that Kinnebrook actually used. And this was made by John Bird. This was actually a telescope that was put together, it was commissioned by James Bradley, who was the third Astronomer Royal. And I don't know how well you can see this, but it's right behind the telescope you can see a clock. And so the way that the observer would operate was he would look at the clock, he would look at his almanac and see what star was coming, then he'd try to find it. And then as he was looking through the telescope, he had a series of 5 spider wires. I'll show you a little graphic of this in a second. And he would have to mark the passage at each of the wires and sort of remember in the mind's eye where exactly it was as he was hearing this, the Graham number 3 clock chime out the seconds. And so you can see how complex this is as an observation. It'd be very, very difficult. This is Bradley, as I just mentioned. I won't talk too much about this because I'm aware that I'm going way over time. But he developed this thing called the eye and ear method. He sort of formalized a way of doing this, which is super important. Every other astronomer for a century emulated Bradley's course of action. And here's a very small representation of what would be happening in the telescope. So these are refracting telescopes, so the east and west get inverted. So the star would be moving, if you're looking to the south, it would actually be moving from what looks like the west to the east. And so this is from Sanford also, and what this is meant to represent is, say you hear the tolling of the chime, you'll think, okay, the star was right about here, and then the next time you hear it, oh, it's right about there. And what you would do is for each wire, you would come up with an estimation of where it was. And I don't know how well you can see this. This is actually from Kinnebrook's letters. And you can see he had very good penmanship. And he would mark for the first wire, the second wire, the third wire, the fourth, and the fifth. Sometimes you see there's like a blank here because maybe it was too cloudy, maybe something was unstable. But the idea of this was that you would reduce the observation of that particular star down to the central wire. And because you had these additional measurements, you could get more and more accurate as you went. So very complicated. I won't read this or have you read this. It's not important that you do, but this is Kinnebrook writing to his father, a very prolix and detailed description of how the marking of observations proceeds. Which shows not only was he learning this from Maskelyne, but he knew it well enough that he could give a very long description, longer than you want to read. You can also read Maskelyne's descriptions. This is not one of them. this is his kind of justification for having fired Kinnebrook. But his description actually tallies pretty well, and this, of course, is the Flamsteed House at the Royal Observatory. The essence of this quote, and I won't read the whole thing again because I'm running low, is that as you're making these estimations, he says, you can accept little bits of noise, like maybe 1/10 of a second, maybe 2/10 of a second, but that's about it. And then he explains like all these confounding factors, but this is part of his description of why he thought it was necessary to fire Kinnebrook. He thought that range of error was too large. Boring calls it a gross error. It's too big to be accepted. Okay. This is kind of funny to me. So we might think of being the assistant to the royal astronomer as being a really good job, really desirable job. And in fact, one of the assistants of Maskelyne actually had put on his tombstone that he had been an assistant to the astronomer royal. So some people really liked it. And this is a description from Maskelyne himself. This was his want ad. He wanted someone to understand arithmetic, geometry, algebra, plane and spherical trigonometry, logarithms, have a good eye, good ears, be well grown, have a good constitution, to enable him to apply several hours in the day to calculation, get up to the observations that happen at late hours in the night, write a good hand, be ready and steady as an arithmetical computer, on and on and on. Sober, diligent, able to bear confinement, age 20 to 40. He found that older people really were not very good. They were too strong-willed. They couldn't observe as well. After this, this is a quote that a lot of people will re-quote from John Pond. He wanted indefatigable, hardworking, and above all, obedient drudges. Okay, so where do I sign? So it's not the most attractive job. This one I rather like, but again, it's a very long quote from Thomas Evans. This was the guy who succeeded Kinnebrook. And he said, nothing can exceed the tediousness and ennui of the life of the assistant, excluded from all society except perhaps that of a poor mouse, which may occasionally sally forth from a hole in the wall to seek after crumbs of bread, on and on and on. Very terrible life. Evans ended up striking up a dalliance with Maskelyne's daughter's governess, and he married his way out of the job, which is important a little bit later. The historian Kevin Donnelly, who's another person who helped me with this, he showed that the word boredom only gets indexed in the Oxford English Dictionary in 1850, and he conjectures that it's a word that people doing positional astronomy came up with to describe their condition. So I don't know how accurate that is. Okay, so let me get to the punch. Geez, I'm running out of time here, so my apologies. All right, so this is the firing of Kinnebrook, and this is from the observations. I want to show you a little piece of the observations in a second. Yeah, thank you. This set of observations goes over many, many years. And so Maskelyne's kind of giving a chronology, even though this is published in 1799, so this might have been written sometime after all this happened. He says, my assistant, Mr. David Kinnebrook, having at this time unfortunately commenced a vicious way of observing the times the transit's too late, it'll be necessary to make an allowance for those errors where his observations, distinguished with the initials DK of his name, are intermixed with mine. That's where one of us observed the star or stars and the other the sun or planet whose place was to be settled from them, from this time to the 19th of January of the ensuing year. And then he says more at the end of the year. This word vicious is interesting if you look it up in the Oxford English Dictionary or Dr. Johnson's dictionary. It means somebody who suffers from some kind of moral corruption, somebody who's got something wrong with them. And so it's not just he didn't do a very good job, it's a little bit more than that. It sounds a little more subversive than all that. And then this is the bit from the end. This is on page 339 of the same volume. And he says, I must mention that my assistant, David Kinnebrook, who had observed the transits of the stars very well in agreement with me all the year 1794 and for the great part of the present year began from the beginning of August last, to set them down a half second of time later than he should do, according to my observations. And then he says, in January, he increased his error to 0.8 of a second, as he had unfortunately continued a considerable time in this error before I noticed it and did not seem to me likely ever to get over it and return to a right method of observing. Therefore, he's useful and diligent and everything else, but I had to part with him. So this is his kind of regretful tone about the whole thing. You know, there's a little bit of sympathy and all that. Okay, so now I'll kind of get to the standard narrative, and I'll maybe talk a little faster. So, as I said earlier, the letters that Kinnebrook had resurfaced in 1985, and they were studied by J.D. Mullen, who's a very eminent British psychologist. He actually is expert on Dalton and colorblindness and so forth, and Perkins, who was the archivist at the Royal Observatory. And they published an article in 1996 in Nature. It's only 2 pages long, so anyone could read it. It's called Errors in Judgment at Greenwich in 1796. And they read through the letters, and they said stuff that happened. So one thing was, Maskelyne got angry with Kinnebrook for breaking a wire in the telescope. He said, you should be more careful in the future, you know, even though Kinnebrook got it fixed. Kinnebrook was asked, do you want to dine with us or dine alone? And he wrote to his father, judging by the drift of discourse, I could tell he wanted me to dine by myself, and he did that, and then apparently Maskelyne was angry about that. And he seemed to be angry about every decision that Kinnebrook ever made on his own. He would ask for time off, and Maskelyne would refuse it in sort of rude terms. And then the final straw was when Kinnebrook refused the hand of Mrs. Wilkinson, who was the niece of Anthony Shepard, who was the Plumian professor of astronomy at Cambridge, and someone who was very influential in getting Maskelyne his position as the Astronomer Royal. I read this wonderful article about the Mrs., and I didn't realize that Mrs. didn't mean a married woman back at the end of the 18th century. It meant a woman who gives orders and is important, is in charge. So I had to reread a lot of Jane Austen and think about what I had assumed in the past. So this is very interesting. So he did not take the hand of Mrs. Wilkinson. And the whole thing is very funny because, as I'll say in a few slides, Maskelyne actually left the observatory for 6 weeks, and he left poor Kinnebrook with Mrs. Wilkinson, who they were trying to marry him to, and they were basically the only people there for all this time. And this is where everything went to hell for Kinnebrook. Then they turned to the data, and this is stuff that I don't have access to because the Royal Observatory Library at Cambridge actually has the original data sheets, which I have not seen. And they looked through the raw data, and they asked, what do the raw data of the transit book reveal? So first, they found that final digit registration was a little more marked for Kinnebrook. This would be like all of us, like maybe you just hate 0.2. So when you're estimating stuff, you do 0.3 or 0.4, but you don't like certain ones. And they can do a little histogram and show which ones you like. And Kinnebrook had more decided preferences for some than others. They also looked at the standard deviation between the wires measurements and found that Kinnebrook's were higher, and they concluded that he was therefore a bad observer. And I find this a little odd because it was known from the middle of the 19th century that fatigue actually affected your personal equation, these experiments that Adolf Hirsch did in Switzerland. So that I find a little odd. So then they conclude very significantly, and they say, certainly Kinnebrook was not a distinguished observer. The pretext for his dismissal was sound, although the real reason for his dismissal may not be the one historically assumed. And I found this to be quite a sentence to try to digest. What does that exactly mean? And so I say here, even if they show that he was sloppy and got sloppier, they were showing irregularities. They weren't showing constant lags. So these things were sort of irrelevant. These are things that Maskelyne would not have even known about. They also were things that he couldn't have known about because they're statistical techniques that no one had back in 1796. So it was his lateness that was the problem. And then I find their sentence interesting because it's so vague. What does it mean to say the pretext for it was sound? Does that mean that it's legitimate because we can come up with some way it might have been right later? That seems to be the standard that they're using in this particular case. Okay, so this is a section where I'm actually kind of defending masculine a little bit, and I can come back to this, but I think he actually sort of contradicts himself in all this, because he says he was confused and irregular, and yet if you just add 0.5 to my numbers or 0.8 at a certain point, you get the same numbers I have. Well, that's the definition of regularity, is that you could do this. So I could talk about this a bit more. This slide I meant to show some oral history. This is Walter Maunder, who was an assistant to Christie around the end of the 19th century. And I found this quote really interesting. He wrote a nice history of the Royal Observatory. And he says of Kinnebrook, the offender was scolded, warned, exhorted, and finally, when all proved useless to bring his observations into exact agreement with the Astronomer Royals, dismissed as an incompetent observer. Nothing like that could I find any earlier than 1900. No comments about the personal dynamics that had any detail to it. So this may have been something that people talked about for 100 years at the Royal Observatory. They sort of knew the story. Yes. So let me kind of get to the punch here a little bit. I feel like I have too many slides. All right. So despite the fact that Mullen and Perkins and others quote the letters, they don't really get deep into Kinnebrook's own defenses of what he was trying to do. Okay, and so it's more these personal interactions. And so here is a important part of the letters. This is a letter from December 17th, 1795. And it's a very trenchant letter. It's written in a tiny, agonized hand. He told his father, if you're going to respond to me, respond in a double letter with a very thick envelope, because he's worried about it being read by Maskelyne. So he's very paranoid. And here he lays out the treatment he's received at the hands of Dr. Maskelyne. Actually, this whole thing is about, the whole letter, the pretext for it, if you will, is about whether David Kinnebrook Sr. should send a Christmas turkey to Maskelyne or not. And then like all this very interesting stuff about, the history of observation is sort of punctuating all this. And then he says, yeah, you should send the turkey. And then he has a PS and he says, oh, by the way, he's been very uncivil to me lately, but not so uncivil that the turkey should not be sent. So I didn't include this part. But anyway, so Maskelyne is off at his living in Purton. He was a cleric, and he would do this certain number of weeks a year. Again, if you read Jane Austen, a lot of the poor people end up getting benefited by somebody giving them a living, and they become a country preacher somewhere. And during the time when he was gone, Kinnebrook got a letter from William Herschel. And if you know anything about the Herschels, his sister Caroline was the great observer, and she discovered her 6th comet. And a few years earlier, I think it was in 1793, this had also happened, and Maskelyne was gone, and the assistant at the time tried to send letters and try to get him to come back, because the only place he could do the observing was at the observatory. And because Kinnebrook read the letter and he corresponded with Herschel about it, Maskelyne got really angry. And when he finally came back, he was irate. Even though, if you read the account here, it sounds like he's doing his job. In fact, there were regulations from the Royal Society that said he had to do exactly this whenever the Astronomer Royal wasn't there. Okay, so that's part of this. Now this slide, I don't know how well you can see this, but this I found very interesting. So Maskelyne leaves on the 30th of September. He's gone till the 18th of November. And even though he said, I'm not going to pollute my observations with this DK guy's observations, all of a sudden, the whole time he's gone, there's no marking of DK, which means, presumably, Maskelyne's doing all this. But of course, he wasn't. He was gone, and everybody knew he was gone, and there were all kinds of letters substantiating this. So again, this stipulation in 1764 said that both the Astronomer Royal and the Assistant Observer had to append their initials to observations in the observation books. So were I to see the raw observations, they would certainly say DK. So he left that out. So I think, and again, I don't think this is an honest mistake, and I can't believe that of people who've read the letters, I'm the first person to notice this discrepancy in the observations. So I think, and I was going to show you, I have the observations here. I could page through and show you the rest of the time, but I won't. But believe me, I could show you that afterwards if you want to see it. Okay, so these are a bunch of other parts from the same letter where it's discussed how he went back and he looked at old observations and found that there were discrepancies there, which somehow Maskelyne didn't care about. He also had some interactions with Samuel Vince, who later became another Plumian professor of astronomy at Cambridge, who hung around the observatory a lot. He's mentioned a lot. And Maskelyne, Vince, and Kinnebrook were at 3 different telescopes trying to measure what's called an immersion of one of the moons of Jupiter. And he realized from what Vince was saying that Maskelyne had told him that Kinnebrook was unreliable. And then, as you see, Vince came back and said they had the majority against him because Kinnebrook and Vince's observations were closer than Maskelyne's. And so this kind of showed that there was an active discussion going on, at least to some degree at the time. This is an interesting quote, and I'll wrap up in just a second, Ed, so I know I'm going over time. He says, Dr. Maskelyne has been teasing me continually about the observations, and I don't think it's probable we shall agree long together. I sometimes think from what has latterly been hinted that he intends to get some other person very shortly. And so this word teasing, you'll notice the way I spelled it, this is also the way Jane Austen spells it. And this is an older usage of the word that has to do with taking the coals in the fire and sort of twisting them around to get the fire to burn. So that's what he meant. So not a good situation. He was being kind of pestered by him. Okay. So I won't go into this, but this is kind of when he finally gets fired. Maskelyne points out that they're too different. This can't be tolerated. I think he stays on until the 17th of February of 1796. He actually learns the day he's supposed to leave from his father because Maskelyne and David Sr. had a correspondence. So Maskelyne didn't bother letting him know when he was going to get evicted from his room in the observatory house. So the story of Kinnebrook is kind of sad. He ends up working as an usher in a school, which is kind of a teacher, and he ended up dying in 1802 at the age of 30. If he'd lived to a ripe old age of 51, he would have been exonerated if he would have heard about what Bessel was doing. Okay, so this is the part I wanted to end on, and I wanted to end 15 minutes ago, so just go in the Wayback Machine to 15 minutes ago and pretend that I was more efficient. So these are the questions that came up to me as I was going through this. I wondered why the most salient pieces of the correspondence are never cited. I mean, presumably the whole reason anyone would be interested to read this was to know more about the controversy about constant differences. And maybe it's because you'd have to change a lot of the story if you took that seriously. I don't know. I mean, that's my naive view. And I also feel like the principle of charity is not extended to Kinnebrook. And I think the standpoint of the person looking at this matters. I think there's a reason that Bessel in Germany, among all of his illustrious genteel colleagues, was the first person to really be interested in Kinnebrook. And to ask questions about the social dynamic and eventually come up with a very rigorous, interesting solution. And yeah, maybe on a personal level, I've had too many bad bosses. I've heard too many people spoken of in glowing terms who I couldn't stand. And I could imagine his plight. So anyway, so that's my conclusion. I'm sorry to go as long as I did. I appreciate your patience, so thank you very much.
Hi. So my name is Walt, everyone. I don't know a lot of people here. But, this isn't the first time I've seen a story that talks about, the tale of longitude and all this sort of stuff and measurements. I always find it remarkable that they talk about tenths of a second so precisely at a time when clockmaking was such an imprecise thing. Is there any sort of broad idea of just how much clock drift you might get over the course of between two clock windings or something? Like, that they'd be so worried about tenths that way when clocks themselves could easily be,
Yeah.
within.
Well, that's a really great question. So one thing I could say about this is Bradley used to use eighths of intervals, not tenths, and it was Maskelyne who actually went to the tenths. And I don't know if this was an improvement or not. It seems to me like if you were trying to figure out those intervals, like, multiples of 2, or the inverse of multiples of 2 would be a better way to do this. In longitude, Sobel goes into some really excruciating detail about just how accurate the chronometers of Harrison were. If you look through Maskelyne's observations, he'll say, oh yeah, I added 2 seconds to the clock today. And then it'll just kind of keep on going. So this is done all the way through. And in a way, that's not completely irresponsible because, like say if you were measuring things between two cities, and this happened a lot in Germany, and we wanted to know how far away like Königsberg and Berlin were, we would both take a measurement of the sun at its apex at noon on my clock, and then you do the same on your clock, and then we would get in a carriage and we would meet up and compare the clocks, and we'd figure out how far away you were. And this was part of the geodesy of that sort of period. And so, but yeah, there were constant calibrations of clocks, and getting maximally accurate clocks like the ones that Harrison produced was really the goal. So yeah, but that's an interesting question. That's the best answer I can give, Walt. So.
Arash Patel asks, where were these correspondences stored for 200 years? It seems surprising that someone who seems as unimportant as Kinnebrook's position, when you discussed how often assistants were hired, it would be like reading the words of a lab assistant 200 years in the future from today.
Okay. Yeah, so the answer to that question is no one really knows who had the letters. So there was someone who came forward who was trying to sell them, and eventually copies of the letters are stored at the National Maritime Museum, and the actual letters are at the Royal Observatory Library at Cambridge. But the identity of the person who was selling them is not disclosed, so I asked about this. You can imagine that it was somebody related to Kinnebrook, even though Kinnebrook's family ended up immigrating to Australia, the next generation. So his father was named David, and his father's brother was named William, and then his name was David, and then his brother's name was William, and then his brother William went to Australia, and he had a son named David. This was the British in this period had a real lack of imagination when it came to names. But the letters are written in a really encyclopedic sort of way. So he gives like a history of the Royal Observatory. He talks about the various rooms, how the different instruments work. So it's not merely just letters home. There's a lot of stuff that seems to be part of some kind of project. And in fact, in a few letters, he references a project that his father wants him to work on, and he's kind of perturbed by this, and he says, you must imagine I have a lot more leisure than I do, and so it's not clear what they are. I had meant to say, too, about the viciousness. There are a few interesting quotes in the letters where he says Maskelyne got angry with him about his manner of living and criticized him, and they got in big disputes, but I can find no evidence in the letters what about his manner of living was so disagreeable. So tried to find it, but I couldn't.
I'm sort of interested in the standpoint angle. Like you totally see why that would matter then, like in the moment, because it's the current social status. What's more surprising is that it seems to still matter now, like in the resistance you're facing when you try to bring this stuff up. That seems somewhat a little surprising to me. Like, because sometimes, looking back, you kind of like the underdog a little bit. Like Carolyn Herschel's reputation has gone up, even though at the time, maybe due to she wasn't sort of given the credit she deserved. She gets more now, right? And it's so because the standpoint is different that we're looking at it from. So I guess I'm curious why you think it's sort of holding in place more in this case.
Well, as I looked at a lot of the articles I was reading, I noticed that they were, people who were fellows of various museums or societies that are tightly linked institutionally and had funding on that basis. And I wonder if within that framework, sort of changing that narrative is maybe not what you want to do. And there are certainly a lot of things that are being written about that are very informative and important, and this problem appeals to me because I'm interested in the personal equation. If you're interested in the totality of Maskelyne's activities as a mature scientist, then maybe this is not that interesting to you. And I think that's part of it, but I also feel like if you were to take on some of this more sort of contrarian history where you're looking at somebody else as maybe the person to sympathize with, that might be harder to manage in that situation. So I believe it has to do with institutions still. And I also think that it's harder to say, it's harder to do what Sobel did if you were an academic than it would be to write a really glowing endorsement of Maskelyne, for example. I think that's the value of having people writing from different perspectives, is that you can tell different stories.
Kind of like piggybacking off of that, I think it is interesting, especially we've been talking about it in class, like social epistemology, like maybe they would have found this stuff out sooner if, he wasn't such a jerk to Kinnebrook. And I think it happens a lot, like even not in like big institutions or like prestigious places, like it happens in everyday life a lot. Like I just think it's interesting that, like for example, I had a bad experience with a boss like a couple years ago. They didn't want to fire him, even though like I had documented all this like terrible stuff and like I was doing a great job. And I just think it's interesting that I think it happens like across the board. It's like it is interesting that it is something that persists.
Yeah, and one thing I wanted to say that relates to this, Kate, is in my bigger paper, I sort of compare the German world with the British world, and this British world at the time was very stratified. So you had this sort of wealthy guy, Maskelyne, who didn't grow up wealthy, but some relative died and they got a lot of money, and he was very genteel, and his assistants were all sort of like poor relations of other people that might be known who'd come in to do these kind of jobs, self-taught people. So Kinnebrook's father was a school teacher who taught mathematics, and both Kinnebrook and his father sent mathematical solutions to the Lady's Diary, which apparently was a real, really important part of the development of math at the time. And Maskelyne officially denied people the capacity to do this. So some of his assistants did this under pseudonyms. And as my friend Bill Sheehan said, even the great William Herschel was guilty of this sin. He would send in these solutions. Whereas in Germany, like in Basel's case, all of his assistants were students of his who were, fairly wealthy, well-educated, who were going on to have their own observatories, or people like Gotthelf Hagen, who was a civil engineer who wrote the most influential book on statistics in Germany in the first half of the 19th century. Just scores of these people who were sort of equals to him, but younger than him. And so they were very collegial. So Basel used to talk about mathematical problems out in his garden while he was digging, and he'd have his students help him. Like Maskelyne would never do that, right? He was too important to do all that. So I think that having a society with these very rigid social boundaries and hierarchies is also part of this story. And Germany, of course, would have had its own issues like this, but they weren't nearly as pronounced as in England. Maybe we've gotten better. I don't know. I don't think so, but I'd like to think so.
I'd like to ask everyone to help me thank Professor Lund. It's fascinating presentation. And I want to remind you all that we're going to do this again